Right, welcome back. This is a continuation of the first video that I made to speak about a bunch of concepts that we normally find in an Angular application, and to also talk about a structure that I think is ideal to kind of keep everything nice and neat when developing with Angular. In this video, I'm going to wire up an HTTP server and get some fake data and then take it from there because we're going to talk about environments, interceptors. I don't know. Yeah, so let's get started, I guess. First thing we're going to do is we're going to create a service. We're going to go to our services folder and we're going to create a new service here. Let's call it account service, so account.service.ts. Alright, and then I'm going to paste my snippet here, service with HTTP client. Just going to rename this to HTTP. Let's call it account service, and we're going to use it. Yeah, again, the same issue as last time, but I won't care about it for the moment. So we're going to use it to, first of all, I'll tell you a bit about the service we're going to use. This is called requests. I guess that's request response.in. They have a bunch of calls that you can make to a fake HTTP server. We're going to take the first one to list the users. That basically goes as we don't want paged. We'll just get the first page, I think. This is the URL. We'll copy the URL and we'll paste it in here when we need it. Right. So get users. Let's call it get users. All right. And yeah, so we're going to return this .http.get, and then we're just going to paste the URL right there. So now that we have our function here to get the users, we're just going to use it in our account component. So we switch over to our account component. Here, same structure as the last video. I want to create a new method here to get users. Let's call it get users. Right, and then we have our account service wired up here, injected. So just create an instance private account service of type account service, and we're just going to call that here account service dot get users. And basically this returns an observable, as you can see here, as the HTTP client works in Angular. We return an observable. So this in itself doesn't do anything. We need to subscribe to it. So subscribe. This should hopefully return an array of users. And then for the moment, we'll just go into console log users from fake API, and let's show those users in a console. Once we have that wired up, we're just going now. The next step is to call this get users here that we just created. So this dot get users, and now basically on ng on init, as soon as the component initializes, we're going to call this, and hopefully you can see this in a console. So let's do that, and let's go to our auth login, log into our app, log in, and then as you can see, users from fake API, and we get the data. This is the actual data that is returned. So maybe we want to do .data, if I can type. Now this complains that data doesn't exist, and that's basically because of my TypeScript linter complaining about that, but it should still work. So I'm going to remove that guard because it gets in the way for what we want to do at the moment. So now see, this works even though we have a complaint here from my tslinter. You can disable it in your tslint.json, but instead of disabling it, I'm just going to put that as any here for the time being. Later we're going to create an interface to hold the structure for this users array. So we have everything now. This when we subscribe, we can either get the response, or if for any reason our request fails or we get any sort of error, you can pass in a second parameter here that holds the error. So console.error for now, an error occurred, retrieving data, something like that. We can even append the error here if we want, and let's just let's go cause an error in our get service. Say for example users, a bunch of s's there, so that should fail. Well, let me just get rid of the guard route in module because it gets in the way at the moment. So comment that out. and then we can go to our account. No issue. Now here, how did that still succeed? Let me check. So that should not succeed whatsoever. I don't know. Really? Oh wow, that actually works. Okay, I did not know that. So let's try to cause a bigger issue here. See, that shouldn't go through. Okay, so that failed. An error occurred retrieving the data. Of course, misspelled because, yeah. We go back to our account component here. So we do not get into this block because we had an error. So we go into this block instead. And if we go back and fix our error here in the service, there you go. Now you should see our users again. After that introduction, we are going to get into the meat of this video, which is trying to set up an interceptor. An interceptor is basically a function that is executed right before a request goes out to the server, and you can also execute it right before or right after a response comes back from our API. So to create one of those, we're going to our root folder, to our core folder, sorry, and then we're going to have another folder here called Interceptors. There you go. And basically, I want to have two interceptors here. Let's just create the first one here and call it what do I call it? Headers.interceptor.ts. Right, you don't have to call it this. You can call it whatever you want. So I'm just going to HTTP interceptor. There you go. They already have. I have a snippet for that, so it's pretty cool. Now we're not going to provide it in the root. We want our interceptors to go in our core modules, as we discussed in the last video. Here, basically, what this does is a header interceptor. You can call it whatever you want again. You don't have to call it this, but it must implement HTTP interceptor. This is the class in Angular that provides basically the functionality that we want to do. It has one method called intercept, which we must override in our class, and that's what we're doing here. Intercept that takes the requests, HTTP request, basically any request you make to an API, to an API or whatever, and next is basically what handles the request. So if you don't do any of this, and you just do return next.handle request, this basically doesn't do anything. This just forwards the original request to whatever is waiting for it, to whatever services, say for example subscribing to it or anything. Here we are going to append a couple of headers to the request. So the use case here is, for example, if you have an authentication API and you want the user to only access specific endpoints when only when they are already authenticated against your server. Here you have a header called authorization. For example, here authorization header authorization. So that's a pair of key values. Here, for example, you get, if you use JWT, you get something like bearer, and then token goes here. Right, so for every request that goes out of your application, this intercepts it and adds and sets these two headers before it sends it to the API. So this is a centralized, neat way to set the headers for your application, for example, right? But for now, it doesn't do anything because we haven't provided it anywhere. And as we said last time, we're going to provide our interceptors and guards in our core module. So here, it's a different syntax. We don't just do this headers interceptor. Headers interceptor. We don't just do that. There's a different syntax here that says provide. We want to know what to provide to this. There are a couple of providers that are by default known to Angular. One of them is HTTP interceptors. And here, use class, and we're going to use our class headers interceptor, or header interceptor. What did we call it? Yeah. And then the third argument here is something called multi, and we want to set that to true. This basically just provides an instance for each each service that asks for the interceptor. All right, so that's the syntax, and now it's provided for our app because the core module is provided to our app in the beginning, right? So let's try this out. Now we have our users from Fake API, but let's go to the network tab here, users, and then headers, because we did provide some headers here. Now let's see if our interceptor actually intercepted this request and appended a couple of headers. And as you can see, we have the accept application.json header that we put, and we have authorization bearer token goes here. See, we didn't have to do anything with the actual request. We just provided this interceptor, and Angular knows to intercept every request that goes out from our application and append this authorization header to it. So that's a very neat way to intercept our HTTP requests. All right, now what if we want to handle the response? What if we want to provide, for example, let's say a centralized way to handle errors in our application, HTTP errors, that is. Or what if for each and every request we want to intercept the response and check if there's an error, and we want to apply some sort of logic to those errors in a central place. In that case, we can provide an interceptor again for that. So we can create another one. Here, let's call it, for example, error.interceptor.ts. Right? You can call it whatever you want again. I think I have a snippet for error interceptors. No, I do not, but I do have one for login. So let's just tidy this a little bit. So call it error interceptor. I changed a couple of things. So yeah, because we have a space here and injectable is not provided, so we need to import it. Tap, we're not going to use tap. We're going to use, you could get rid of this pipe here. And there you go. So far we're not actually doing anything. Let's just get rid of that line there. So far we're not doing anything really. We're just taking the request and we're forwarding it to the next handler. What we want to do here is to actually apply some logic here. So we pipe catch error, catch error here. I may want to provide it. So error. There you go. Let's import that from RxJS, but because that doesn't really exist, import catch error from. This is imported from RxJS/operators. Right, and that should work. Now it's complaining because it needs to return something. Currently we have void. Let's just console log if there's an error here. Console log error occurred on interceptor level, right? Let's add a couple of things to make it, actually not log, let's warn here to make it yellow. Okay, error, and this expects us to return, sorry, it's called error, and here, this expects us to return an actual, an observable. So we're going to return throw error, sorry, there you go. So now we handled the error centrally, right? So this is our error handling clever method here. So let's try to provide this again in our core module. Right, same syntax as before. We do provide same thing, HTTP interceptors, use class. Here you have a couple of methods: use factory, use value, use existing. For now, we're just going to use class. I don't want to get into details of all those. Error interceptor, and then again same thing, multi is true. If I can type today, there you go. And hopefully here we don't have an error, so that has no reason to show up. So let's try to cause an error. Account service, that's where we have our URL. So let's change a couple of things, ssddd, just to make sure there's an error here. And now if you look at it, error occurred at interceptor level. This is the first thing we see. All right, this error is just a console log statement I added to our error interceptor. Here, so you see this. Actually, we don't need that. So if that runs and there is an error indeed, we should see this error occurred at interceptor level as the very first thing. So that is how you handle your errors centrally, and then you can either throw the error to the next handler, or you can do return off some data here if you want your observable to go on normally. Right, so that's an error handling observable. Let's go back to our account service and speak about a couple of other things. Account service, let's just get it back. Right, you see how we have in our service, we have our API base URL hard-coded here. That's generally a bad practice in Angular. We want this to be provided again centrally. So if we are to make a change to our API, say for example we get API/v2, we don't have to go through everything, every service we have, and then append v2 to it. So there are a couple of ways to fix this. You could do a configuration file. But instead of a configuration file, Angular already provides one here. This is called environment. People, especially beginners, are afraid of these environments, but they're nothing but places where you can have your central data or central constant, if you want to call them that. So for example, we have this URL here. Now let's take one approach is definitely to take the entire thing, right? Let's take the whole thing and put it in our environment.ts. Now we have two of these, as you can see. We have environment.ts and we have environment.prod.ts. So if you build Angular just a normal dev way, you use this environment.ts. But if you build --prod, if you build a production version, you will use this environment.prod.ts. And this is actually specified in your Angular.json. If you go here, there's something called file replacements. So configurations, production, file replacements. Now you replace at build time, you replace source environment.ts with source environment.prod.ts. And what this does is just basically goes with some optimizations for for a production app on Angular. So you may want to put your variables in both of them, or if you're mounting the environment files at build stage, then you may want to have a couple of other things here, and you just copy if you have your script to copy one into environment and environment.prod.ts. Right, as you can see here for the dev one, we have production false, and then here we have production true. It just tells Angular basically that it needs to apply some production logic to it. For now, we're just going to use this, the dev environment, and here we can add. This doesn't really take it looks like JSON, but you can't really do something like app, and then you take JSON here, and then you take other things here. It may complain about that. So just keep it simple, key value, and that should work. What did we want to provide here? Yeah, API base URL, right? API base URL, and let's paste our API URL here. And now in account service, instead of calling the URL or hard coding the URL, we just do environment and make sure you get the correct environment dot API base URL. And that should work as intended if we don't have any issues. Why is that failing to compile here? Sorry. Oh yeah, we have this. Sorry. So now that should work, and we get exactly the same, result as before. But that's also a bad practice, because we have /users. This could change. You don't want to hard code, or you don't want to put all of your URLs in your environment file. So the good practice is to only keep the base URL here, the thing that repeats itself for every request you make, and then the rest you can handle them in different ways. You can do, for example, you can do them here. You can do /users here, right? And that should work exactly the same as before again, right? But in this case, you don't have the base URL hard coded, and you have your /users here in the service instead. An even better practice, I think, is to have a config file where you can have all of these URLs. So in our shared folder here, we can have another folder, call it config, and this will hold all of our configuration values. Here I like to create a file called constant, right, .ts. And this is nothing but a constant export constant. I like to call it constants like that, constant in French. Yeah, so that is basically just a JSON. That's a plain JSON object. Here I like to have something called URLs, and here let's say, for example, users URL, right? And here we can do this. We can do the following. that environment dot API base URL slash users. Right, so now we're calling our API base URL and we're appending the users to it in our constants file, right? And then in our service, instead of calling this, we only call, so basically that is more centralized. We do constant like that, dot URLs dot users, right? And then basically you can have all of your URLs here. The reason why I have URLs and are not just these flattened out is because, for example, I want to have my HTTP options here, right? If I have any headers or anything that I want to have centrally here, if you don't want to use an interceptor for that. So there you go, URLs, users. This is, I think, a good practice. Because if you want to change anything, if you want to change the base URL, you change the environment, you change it over here. If you want to change any of the URLs, basically you get a bird's eye view of all the URLs of your application, basically in one file. So there's that. All right, so I think that brings me to the end of this video and the end of this series. It was 2 parts where I tried to explain some of the structural best practices for Angular apps. I think I'll continue making these videos. I don't know. If you have any question or anything, please just leave a comment below and I'll try to answer it. All right, I'll see you next time. Thanks for watching. Bye.